Welcome to Chapter 5 of Squircle Time. In this video, I'm going to introduce the signum function. The signum or sign function is fairly intuitive. Signum of x outputs 1 if x is positive, -1 if x is negative, and 0 if x is 0. The graph looks like this. All -1 on the left, a discontinuity at 0, and all +1 on the right. I'll always refer to this function as signum and not sign, so as not to confuse it with the trigonometric sign. Since where we'll have signum, we're very likely to also have a sign somewhere nearby. Now, an important property that the signum function has is that the absolute value of x equals x times signum x. Now try to remember how many absolute values we've seen floating around so far. This gives us a great way to algebraically manipulate our absolute value signs. Our other main way of using the signum function will be in calculus. As it turns out, the derivative of signum is 0. If we take a look at the graph or its definition, we can see that signum is essentially a constant function, save for its discontinuity at 0 where the derivative doesn't exist. So the derivative of signum is 0 for all x not equal to 0. We can apply this idea of signum being a constant function to the derivative of the absolute value of x. Using our oh-so-important identity of the absolute value of x being equal to x times signum x, we can remove signum as a constant, and our derivative of the absolute value becomes just signum. Taking another look at the graph, we can see that there's a sharp turn at x equals 0, meaning the derivative should be undefined there. Since signum of 0 is undefined, we'll just have to say that the derivative of the absolute value of x is signum x for all x not equal to 0. There are a few other properties of the signum function to note. The first is that since 1 and -1 are their own reciprocals, signum is always equal to its reciprocal, except when x equals 0. With this, we can also rewrite the derivative of the absolute value of x as simply 1 over signum x, since this function is undefined for x equals 0. The next property is that the product of signums is the signum of a product. No matter the sign of a or b, they'd combine and cancel the same way when multiplied inside or outside of the function. The final property is that signum of x to a power is equal to signum of x to the power. This is following the same ideas as the previous property. If n is 2, on the left side, the result will be either 1 or 0, since any real number squared is greater than or equal to 0. The signum with the power on the inside will also be either 1 or 0. To close, the most important thing I want you to remember as we head into some Squircle calculus is that the absolute value of x equals x signum x. Signum is a constant function almost everywhere, and the derivative of the absolute value is signum x. Bye!